Hey guys, welcome to another lesson in Introductions to Material Science. Today's topic that I'm going to teach you about is failures of metals. So, as I was saying, metals are used constantly and frequently, but have you thought of when it starts to fail? It can lead to heavy consequences, which is what makes this topic a very important one. On the agenda, we'll be covering a variety of subjects, starting off with the introductions. We'll then cover the possible sources of failures before finally talking about the different types of metal failures. Under sources of failures, we'll cover poor designing, material selection, misalignment, improper service conditions, imperfections in materials, deficiencies in processing, and finally inadequate maintenance. We'll cover each of these and their definitions in the lecture slides that follows after the video. For the types of failure, we'll be covering two different types of fractures, namely ductile and brittle fracture, and then we'll get into metal fatigue as well as metal creep. Now, a little more about metal failures. In an engineering plant, the failure of one unit or even a small component may result in a complete shutdown or at least a serious loss of production. It could also lead to a damage of equipment or even the loss of lives. Understanding the modes of failure would help to determine the possible causes of failure and prevent any recurrence. Most failure occur gradually, usually in three steps, namely initiation, growth, and propagation. In a failure investigation or analysis, a systematic and comprehensive approach has to be adopted before corrective action can be recommended or applied. And this is why it is important to have a strong understanding of the possible sources of failure so that you can identify and address the root of the failure effectively. As mentioned earlier, we'll be covering 4 different types of metal failure, namely ductile fracture, brittle fracture, metal fatigue, and metal creep. We'll be going into a little bit more details for each of these right now. Let's first talk about ductile fracture. This fracture is a result of applying excessive tensile forces to cause permanent deformation prior to fracture. A common instance would be when a tensile specimen has necked down before fracture, also known as overload failure. There are several points to note in the identification of ductile fractures. Firstly, the fractured surfaces of the specimen will show a cup and cone appearance, with the cup showing many irregular surfaces at about 45 degrees to the tensile axis, which accounts for the fibrous look. Ductile fractures also typically show transgranular cracking when examined microscopically. And now we get to brittle fracture. Brittle fracture is categorized by the small amount of work absorbed, with little deformation and chevron markings. It can occur at low stress with great suddenness. Several conditions are required to produce a brittle fracture. Firstly, the ambient temperature must be below the transition temperature. Secondly, there must also be a notch present due to the severe stress concentration. Lastly, there must also be the existence of a tensile stress. And the next type of failure is fatigue failure. Fatigue failure is failure of material under repeated applied stress. The stress required to cause failure, if applied a large number of times, is much less than that required to break a material in a single pull. Very few structures in service are subjected to purely static loading. Variations usually occurs in live load during operation due to a change in temperature or the pressure vibrations due to wind load. Dynamic loads in machinery will give rise to fluctuations of the working stresses in the structure. To illustrate this concept with an example, we have performed a simple experiment that you can do yourself at home. Let's go take a look! In this video, we'll be doing a demonstration of fatigue in metal with a simple experiment. Here is a paperclip which, as you can see, has been unfolded into a wire. Now I'm going to bend it back and forth with my bare hands to simulate the cyclic load which will result in the paperclip to break. By imposing fluctuating forces through the means of this back and forth motion, I'm causing metal fatigue, which is the phenomenon when material starts to fail, breaks, or ruptures under a much lesser load compared to what it could sustain in case of static or stationary loading. Imagine yourself as an engineer building a bridge. You'll have to take into account the fluctuating loads that can be due to rainwater or the weight of the traffic on the bridge that could cause the material to restructure due to back and forth loading. All this could cause catastrophic failure if unaccounted for, resulting in heavy losses. Many times, corrosion can make the fatigue worse, but we'll get to that in another lesson. That's all for now. And welcome back! Now we're at the final type of metal failure known as creep. Now, if this is the first time that you have heard of creep in the context of material science, it's probably a little different from the definition you already know. So, in this case, creep refers to the slow plastic deformation of metals under a constant stress. It can cause fracture at static stresses much smaller than those which will break the specimen when loaded quickly. It becomes increasingly important to consider creep in situations where metals and alloys are stressed at a temperature in excess of about 1/3 Tm, where Tm is the melting point in Kelvin if you remember. Or simply put, I'm referring to situations where equipments are operating at very high temperature. The problem of producing alloys capable of supporting stress at high temperature is one of the most exciting tasks facing the metallurgists at the present time. One of the classic examples is where alloys for airplane engines are already being used at high heat of 800 degrees Celsius, yet have a satisfactory service life of several thousand hours. And now we've reached the end of this video. But here's something else for you to look forward to. In this module, you will have to go through a series of assessments, and one of the first few things you have to do is a case study write-up. A case study will be assigned to your group at the website, so you can look forward to that. And after you have submitted your write-up, you will actually have to assess your peers' write-up as well and give them a rating for their report. Secondly, you have to go through a tutorial exercise where you have to go outside and take photos of real-world metal failures to share and discuss with your friends here. Lastly, you have to go through a final assessment quiz with several questions based on the lesson material. After this video, there will be a full set of slides covering the content we've gone through in more detail, so make sure to go through it and study hard for the quiz. Good luck!